Welcome back to the ICND1 series, and in this video we'll be carrying on from the next video, and we are going to be looking at setting up a basic network. So in the previous video we set up the base configuration on the switch so that we can configure basic security on the switch and enable basic network connectivity on the switch as well. However, a network consists of more than just a single switch. A network consists of tens of switches which are connected together, which allow hundreds of hosts to connect to our network and those devices have the ability to share information and communicate with each other. And normally a local area network would consist of multiple switch-to-switch connections like this, with some of the switches connecting to end devices like our PCs and our printers. So we've done the base configuration, but we haven't really set up a network at all. In this video we'll be setting up a basic network and seeing how devices in a basic network are able to communicate with each other. So what we're going to do, we're going to have a PC connected to a switch. This is going to be switch 1, the switch that we configured in the last video. We're going to run through the base configuration of configuring switch 2 again. Switch 2 connected to another PC. And then we're going to give these PCs IP addresses in the same network and see if they're able to communicate. As well as seeing if they're able to communicate, we're also going to have a look at the MAC address table on switch 1 and switch 2 and see the actual table a switch will use to forward data to the correct destination host. And we'll also be looking at the ARP table on switch 1 to see how switch 1 knows the MAC address to use in order to reach PC 2. So again, we're going to be setting up two devices with IP addresses and seeing if they can communicate with each other. We're going to have two PCs and two switches, and we are going to have a look at the MAC address table and the ARP table. So when we're configuring our switch, there are two types of devices that a switch can connect to. A switch can connect to another switch or another hub. Or switch can connect to another set of devices such as routers, PCs, printer servers. So like devices, devices that transmit on the same pin pairs, and devices that don't transmit on the same pin pairs. Normally, when we have a switch-to-switch connection, we would configure those ports on either side of that connection, so the ports for that connection, as trunk ports. A trunk port carries traffic for multiple VLANs across a single link, across a single port. So we know that by default, switches, all ports on a switch are in the same broadcast domain. With VLANs, we're able to segment and separate our switch into multiple broadcast domains for additional layer 2 security. So with VLANs, we can split up our switch into multiple broadcast domains. So in this case, if these two ports were in VLAN 1, these two ports were in VLAN 2, and these two ports were in VLAN 3, essentially, if a broadcast message was sent by a device in VLAN 1, that broadcast message would only be sent at this port. It wouldn't be sent at this port or this port or this port or this port, because they reside in different VLANs and therefore are in different broadcast domains. And the reason why we would use VLANs is for additional security at layer 2. We will get into VLANs in later videos, but just know for now that this is a feature that we can configure on our switch. So instead of all ports being part of the same broadcast domain, we can separate our switch into multiple broadcast domains known as VLANs. And it's a trunk link, in this case a trunk connection, which would be used to catch traffic for all these VLANs across a single connection to another switch. We can also configure a port as an access port. Normally, access ports are used to connect to end devices such as PCs, printers, or routers, and trunk ports could also connect to routers when we're doing router on a stick, when we're routing between our VLANs. But again, we'll talk about that in later videos. So I'm going to pause the video for a moment, and then I'm going to load up a console connection to our second switch. Welcome back. So I've loaded up a console connection to our second switch, and again, when we first boot up a switch and it doesn't have a startup config file, the switch will always ask if you want to enter the initial configuration dialog. This is a legacy kind of like program or a legacy mode which walks you through setting up the base configuration of a switch. We always enter no in this case, or N. Okay, I'm gonna quickly run through the base configuration. So we're gonna move from privilege mode into privilege exec mode, move to global configuration terminal, and then we're going to configure the host name of the switch. In this case, call it switch 2. Pretty simple. Then we're going to configure security on the console port. Set the password to Cisco. We're going to tell the switch that when we're on the console port, do not keep interrupting our commands with system messages. If you can issue a system message, do it, and then move our cursor over down to the next line. We're gonna tell the switch that don't time us out if we remain idle, since this is just a lab. We're gonna move into the VTY lines, and again we're gonna configure security on the VTY lines. We're gonna give a password to Cisco and log in. We're gonna configure an enable secret, so there will be a pointer for password when we move from privilege mode into privilege exec mode. Now we're gonna go under interface VLAN 1, and we're gonna give it an IP address. In this case, we're gonna give it the IP address 192.168.1.11. We gave switch 1 the IP address 192.168.1.10. Again, this IP address is just for management purposes, so that we can telnet or SSH into the switch and configure it remotely without having to actually have a console connection into that Cisco device. So I'm going to shut down. And lastly, we're going to configure the login banners now. So banner. I'm going to configure an exec banner. This is my delimiting character. This is an exec banner. Now we're going to configure the message of the day banner. This is the message of the day banner. And we're going to configure a login banner now. This is the login banner. If I can spell. So we've briefly just run through the base configuration of a switch. And now what we're going to do is, if I could draw it very quickly, and this is what I've got kind of now, with a PC which connects to switch 1. Switch 1 has got the base configuration, and we've got a connection to switch 2 and a connection to another PC. In this case, we have fast Ethernet 0/1 running from switch 1 to the PC, fast Ethernet 0/2 running from the PC to the switch, fast Ethernet 0/1 running from the switch to back to this other switch over here, and fast Ethernet 0/2 which connects to this PC. We need to configure fast Ethernet 0/1 on switch 1 and fast Ethernet 0/2 on switch 2 as access ports, since they connect to end devices. And we're going to configure this link here. So we're going to configure port fast Ethernet 0/2 on switch 1 and fast Ethernet 0/1 on switch 2 at the trunk port. Since this is going to be another switch to switch connection, and it's going to be carrying traffic from multiple VLANs over the single link. Now we don't have multiple VLANs configured on our switch, but it's just best practice, and in general, anytime we have a connection to our switch, we just configure that as a trunk connection. So in order to do that, I have to go into interface configuration mode. So the first thing I'm going to do, I'm going to configure on switch 2 interface fast Ethernet 0/1 as a trunk port. So to do that, go into interface configuration mode for fast Ethernet 0/1. I'm just going to use the command switch port mode trunk. So this configures it as a trunk port. I'm going to go under interface fast Ethernet 0/2, and I'm going to configure this as an access port with a switch port mode access command. Okay, now I'm going to save my commands so that I don't lose them in case the switch powers off. And now I'm going to move to switch 1 and basically just do the exact same thing. I'm going to configure the correct port as access and the correct port as trunk. So here I am at switch 1. I'm going to move into global config mode and then into interface configuration mode for interface fast Ethernet 0/1. I'm going to configure this one as an access port, switch port mode access. And I'm going to move into interface fast Ethernet 0/2 and configure that as a trunk port, switch port mode trunk. So interface fast Ethernet 0/1 is an access port, and interface fast Ethernet 0/2 is a trunk port. So now we should have all the means to allow PC1 to communicate with PC2. So now I'm gonna open up the terminal on PC1, which is over here, and I'm gonna see if PC1 can actually in fact ping PC2, ping 192.168.1.30. And as you can see, it can, so that's successful. That means that PC1 can communicate with PC2, and PC2 can send that data back. Now I'm gonna see if PC1 can now ping the IP address of switch 2. Indeed it can. And I'm going to see if it can tell it now into switch 2 for remote management purposes. And it can, so I'm putting for a password. We can see the messages of the day banner, the login banner, and then the exact banner after we have entered the password and have access to privilege mode. Move into privilege exec mode, and I'm going to exit from here. So we have confirmed communication between PC1 and PC2. Now that we've done that, let's see the MAC address table of switch 1. So to bring up the MAC address table, the table a switch uses to forward data to the correct device, we use the show MAC address table command. And see, when we first look at the MAC address table, we can see a lot of static entries which point to the CPU. So by default, a switch listens on specific MAC addresses, mainly for multicast. And whenever it receives frames with a destination MAC address of one of these MAC addresses, it sends that data to the CPU to be processed. So by default, there are a lot of static entries in the MAC address table for MAC addresses that the switch should listen on for destination MAC addresses, so that if the switch receives a frame with one of these MAC addresses set as the destination MAC address, then it should forward that data for that frame to the CPU to be processed. So by default, there's a lot of static MAC addresses. No, there are a lot of MAC address entries which are static that the switch itself should process frames for if it receives a frame with that MAC address set as the destination. Now with the dynamic entries, these are normally learnt as a switch receives frames. So as devices in traffic, the switch will receive frames and forward those frames accordingly. These dynamic entries normally indicate or normally tell the switch how it can reach the devices that connect to our network. So as you can see, switch 1 knows that to reach my laptop, in this case with the MAC address 1C75.080.1786, it can use port fast Ethernet 0/1 to reach this device that resides in VLAN 1. And it knows that to reach PC2, so PC2 actually has this MAC address over here, it can use interface fast Ethernet 0/2. Now as you can see, there are multiple MAC addresses associated with a single interface. When I see this, this tells me that this interface over here must be a trunk interface or an interface to another switch, because I can reach multiple MAC addresses using that single interface. So now we're over on not PC, but now we're over on switch 2, and we're going to have a look at switch 2's MAC address table. So again, you can use the show MAC address table command, and if we just want to see the dynamic entries, so not the static entries that the switch itself should respond to, I should listen for, we can add the dynamic keyword. This tells the switch only display the dynamic entries in the MAC address table. Press enter. So as you can see, switch 2 knows that to reach my laptop. So let me just generate some more traffic, because that entry might have timed out by now. Let me just go to another ping 192.168.1.30. I'm not telling that, sorry. Ping 192.168.1.30. So if the switch doesn't head traffic from a device for 300 seconds, it times out its entry in the MAC address table. This is probably why the entry for my laptop is missing. So as you can see, the entry is not added again. It had timed out because no traffic was flowing from my PC to PC2, from PC1 to PC2. Now that I've generated some traffic, it's added that entry again to the MAC address table. So the switch 2 knows that to reach my laptop, it can use port fast Ethernet 0/1, and it knows that to reach the PC2, it can use port fast Ethernet 0/2. So if I can do this out very quickly, here's my PC or my laptop connected to switch 1, which connects to switch 2, and which connects to the PC2. connection. So, from switch 1's perspective, it knows that to reach my laptop it uses port fast Ethernet 0/1, and that to reach PC2 it uses port fast Ethernet 0/2. Switch 2 knows that to reach my laptop it can use interface fast Ethernet 0/1, and to reach PC2 it can use interface fast Ethernet 0/2. So now, when my PC sends traffic to this PC over here, so when PC1 communicates with PC2, switch 1 is the first switch to receive the packet. It looks in its MAC address table and sees that to reach port PC2, it has to send that traffic out fast Ethernet 0/2 over the trunking to switch 2. When switch 2 receives the packet, it knows that to reach PC2 it has to send that data out fast Ethernet 0/2 directly to PC2. So because these switches have that table and they have this in intelligence built in, it means that they can send traffic directly from PC1 directly to PC2 without having to forward traffic to any other device and bothering any of the other devices, which is what hubs used to do. So switches are highly intelligent devices, and we can see this now. So by looking at the tables, we can actually see how switch 1 knows how to send traffic to PC2, and knows that in order to get to PC2, it sends it directly to switch 2, and switch 2 can send it directly to PC2. So now that we've looked at the MAC address table, let's look at the ARP table of our PC. So the MAC address table shows how switches know how to reach certain devices and what ports to use to reach certain devices. But when I wanted to communicate with PC2, I typed in the IP address of PC2. How does my laptop know the MAC address of PC2? And we explored this in an earlier video. Devices in an Ethernet-based network actually use the ARP protocol in order to map the IP address to the MAC address. So if I open the ARP table, we can see that my PC knows that to reach PC2, it has to send traffic to this MAC address, and that to reach switch 2, it has to send traffic to this MAC address. So, but how did it learn of these MAC addresses? By using the ARP process. So was the ARP process? My PC essentially sends a broadcast message, a broadcast ARP request to all devices on the network, saying that if this is your IP address, so if you have the IP address of 192.168.1.30, please respond back to me with your MAC address. PC2 receives it, processes the packet, sends back an ARP reply which flows directly to PC1, and in the ARP reply it will list this MAC address, so that now PC1, my PC knows, in order to reach PC2, it can use this MAC address, this MAC address over here, in order to reach the device. So we've reached the end of this video, and we've looked at how to set up a basic network. We've gone over the base configuration of a Cisco device, and we've actually seen the MAC address table. So we've seen the table a switch uses to forward traffic to the correct destination device, and how it can use this intelligence was built in to ensure that data is delivered to the correct host and only that host. And we've seen the ARP table, the table that devices use in order to identify the MAC address that they should use to reach a particular device on our network. I hope this has been informative for you, and I would like to thank you for viewing.